Okay, so now we look at what are called multiple trees, and these methods have empirically they have been shown to uh, produce more accurate predictions. So this is a different method, but the basic idea is the same, the efficiency. Now instead of growing the efficiency to the fullest extent and then pruning back to the level that we want, instead of that, so we're going to grow lots of little trees, bushes, and then combine them all. So that's why it's sometimes called ensemble methods. Okay. So draw multiple random samples with replacement. Okay. So this sampling method is called bootstrapping. So when you take a sample, when you sample, then put it back, check it up, sample again, put it back, check it up, sample again. So that kind of sampling is called bootstrapping. So select a random subset of predictors. Okay, so you're not going to use all the predictors for each tree, like what we did with the regular decision tree. So you have like 50 different predictors, you randomly select 5. Okay? And then build a tree. So this is going to be a small tree because you're only doing a subset. You're using only a subset of predictors. Okay? So then repeat. So you draw a random sample, bootstrap sample, then you draw a random subset of predictors, and then you fit a classification or regression tree, whichever the case may be. Okay? And then you repeat 1 to 3, and then you get a bunch of trees. So that's why it's called a forest. So combine the predictions from all these individual trees to obtain an improved prediction. So in case of classification, then you will use vote to mean how many zeros are there, how many ones are there. The more predominant class wins. Okay? If it is a numerical target, then you make an average of the predictor variable for each of those trees. So averaging for prediction. Okay, so we're going to use a library called Random Forest. We have library Random Forest. I have it here. I don't know whether you have it in your machine. Okay, if you don't, then you have to install Random Forest. Okay, and then so here are some of the parameters. So if you want to find out what all the parameters there are, so you can, in the console, you can do a question and then the random forest, and then will give you helpful information right here. So all of that information. Now I've selected some of them which are more common. So you can use n3, so to say how many trees we want to grow. So randomly select a subset of predictor variables. So how many random sets we want to select? Okay, so default is 500. Okay. Young try is how many variables you want to sample a candidate at each split. Okay. And here is the defaults are given here, square root of p being the number of variables, or p over 3 for regression. Okay, replace is whether the default is true, so whether bootstrapping sampling should be used or not. Then you can specify node size and maximum nodes, and then you can also say you want importance or not. So importance here means which variables are most important. Okay. Important variable in descending. So all of those can be requested. So once again, since this is a cross-validation, sampling is involved here, so you need to say set seed. So bank forest. It's a random forest. Now it needs, instead of class equal to or method equal to class, you specify the target as a factor. So classification tree will be used. Personal dot name. Okay. And data equal to train df. Okay. So we can say n3. Then 500 is the default. So if you want to use different numbers, 300 or something, and then try 4. Importance equal to true. Okay. All right, now we can print the importance for the variable plot. Okay, so if you say importance, okay, and say bank dot rf. Okay, so it's going to give you the importance in this way. Okay, so now the default thing is type 1, mean decrease in accuracy. So you can specify which way we want. We want minimum decrease in accuracy, so which would be type 1. Okay, so if you say here type 1, then it will give you based on accuracy. So if you say type equal to 2, it will give you minimum decrease in gene. Okay. Or if you don't specify anything, it will be mean decrease in accuracy, but it will give you all the information that you want. And you can plot, you can prepare a plot of the importance. Okay, so that is var import var imp plot. Okay, and bank dot rf. Okay, so it gives you both mean decrease in accuracy and mean decrease in G. And once again, you can specify the type you want. So if you want just one of them, you can say type equal to 1, type equal to 2. So here, this means income is the most important variable. Then is education, family, and so on down the line. Okay. Now, confusion matrix. Okay, so here you get the confusion matrix for trained data set, just simply saying bank dot rf. Okay, so you have confusion here. Okay, so, but this one is only for trained data set. So usually we don't care about trained data set in terms of confusion matrix. What we really want is the validation data set. So for that, we have to predict and And this is how you do for all other models too. Okay, so you have to run the predict method using the model, which is bank.rf, and then valid.df. And then you do the confusion matrix, okay, like what we have done previously. Okay, so valid.rf.thread, okay, so that is your predicted class, and then you have to do valid.df personal loan. That gives you the now positive class is 0, and if you want positive class to be 1, you can specify positive equal to 1. Okay. All right. And then if you want ROC curve, then you have to compute the probabilities. Okay, let's go ahead and do that. You need library P ROC for that. Okay. And then we need the probabilities. So like prediction, instead of prediction, we need probability. So we use the predict function, predict, same code like what we had here, right? So same code now, but we need to specify. Okay, so we don't want two predicts. We need to specify what we want for predict. So we need to say type equal to raw. So now okay, so this look at how what is generated here. When you do the prediction, it creates a matrix of probability. But we don't want matrix, so we need that to be a data frame. So you enclose that code within data frame method, so you get valid.r.row as a data frame. So now let's go look at the data frame. So it has except 0 and except 1. Sometimes you'll have V0 and V1, okay, as probability. So that's not very good. So let's go ahead and create names for it. So names valid.prob equal to, I don't know, P0 and P1. Okay. So that's P0 and P1. And then once you have the probability set up, then we can run the ROC. So ROC will be for PTY equal to S, and then ROC valid.df personal loan, so that's our actual class. And then we need to give the probability. Actual class is the valid data set, and then the positive class is 1. So we need to specify the probability for the positive class. So there are 2 columns in this probability, P0 and P1. So we have to select P1, and then we say plot equal to true, and then all the rest of it. Okay, so I'm going to just leave it like that. Okay, so that is your ROC. And you have lots of other formatting options that go with the ROC, which we've gone over several times. So you do all that.